Okay, so this video is about electrolysis of solutions. When I'm talking about a solution, I'm talking about an ionic compound that has been dissolved in water usually. So when we're looking at GCSEs, we're looking at compounds that are dissolved in water. So for example, I might have copper chloride solution, and I would show that as being aqueous. Aqueous just means it's dissolved in water. When we've got something that's dissolved in water, it's a little bit different to when we're doing electrolysis of a pure molten substance. If we're looking at a pure molten substance, we only need to think about the ions that are making up that substance. So in this case, we're looking at copper chloride. So we've got our copper ion, that's our positive ion, and we've got our chloride ion, and that is our negative ion. And we have two of those in that molecule, but I'm only interested in looking at the ions that are present. Now, if I was looking at just molten copper chloride, it would be really simple. I would expect my copper to travel to the cathode, which is the negative electrode, and my chloride to travel to the anode, which is the positive electrode. And that would be what I would expect to see. Things become a little bit more difficult when we've got water, because when we dissolve an ionic substance in water, water does not stay as a covalent compound, or not all water does. So what happens is water actually ionizes as well, and we end up with hydrogen ions being produced and with hydroxide ions. So when we're looking at an aqueous solution, we actually have 4 different ions that are in that solution. We have our 2 positive ions, and we have our 2 negative ions. Now, in the case of copper chloride, actually the hydrogen ions and the hydroxide ions that are from the water, so everything over here, just stays in solution. So we do see copper forming at the cathode and chlorine gas forming at the anode. However, this isn't always the case, and it depends on the reactivity of the ions that are involved. So let's look at another example. So in this example, we're looking at copper sulfate, and again it's an aqueous solution, so we know that that means that we have water. So the ions that we're looking at here, we're looking at our copper positive ion, and we're looking at our hydrogen positive ion. And here we're looking at a sulfate negative ion, and we're looking again at our hydroxide negative ion. Now, in this case, we have a competition going on. So the competition is between our copper and our hydrogen going to the negative electrode, and between our sulfate and our hydroxide going to the positive electrode. So what actually happens in this case? Well, in this case, the one that wins the race is copper. So copper comes off at the negative electrode. Our hydrogen does not manage to win that race. And when we're looking at our negative ions, well, looking at our anions going towards the anode, it is the hydroxide that wins that race. So the hydroxide wins that race. We would expect maybe that would give us hydroxide or water at our positive electrode, but that isn't the case. Actually, our hydroxide ends up being oxygen gas. And so in this case, oxygen gas is what is given off as bubbles. At GCSE, you have to be able to predict what is going to be added or come off at each electrode. So come off if it's a gas, or added on if we're looking at a metal. Fortunately, there's a very limited number of ions that we can look at for each electrode. So at your negative electrode, so at your cathode, what you are going to see is you are either going to see copper ions winning the race, silver ions winning the race, or hydrogen ions. So what we are going to see, we are either going to see copper metal, silver metal, or hydrogen gas. Those are the three things that we might see. When we look at our positive electrode, then there's again only three things that we're likely to see. So we might see chloride ions, we might see bromide ions, or we might see hydroxide ions. And these make three different gases, so it's always going to be a gas. So we might see, in this case, chlorine gas, we might see bromine, we might see oxygen. So how do we work out which ion is the one that's going to make it to the electrode, or what we're going to have for different chemicals? What you need to do is you need to have a look at the chemical, and there's some really easy tricks that we can use. So first of all, if you can see that the chemical contains copper, then it's going to be copper that comes off. If you can see that it contains silver, it's going to be silver that comes off. If it is any other metal, literally any other metal, then what you're going to see is hydrogen. So if it says copper in the chemical formula, if it says silver in the chemical formula, that's going to be the metal that comes off. If it says any other metal, then you are looking for hydrogen gas coming off. The same for when we're looking at our negative ions. So if it says chlorine, or it's got a chlorine or a chloride in the name or in the formula, then it's going to be chlorine comes off. Again, the same for bromine or bromide, that's going to come off if we see it in the chemical name or the chemical formula. If we see sulfate, so if we have sulfate, that is going to form oxygen, and this is because sulfate does not win the race against the hydroxide ions from the water. It's the hydroxide ions that win the race, and they make oxygen. So if you see sulfate, you know that you're going to have oxygen that is going to bubble off at the positive electrode. So now it's time to test yourself. I want to know what will be the product at each electrode for aqueous solutions of silver chloride, copper bromide, magnesium sulfate, sodium chloride, silver sulfate, and zinc chloride.